Hey, this is Dr. Shulman again. So this is Math for Teachers, all the elementary sections that you're going to be tested on when you take that exam. I did all the types of addition and subtraction ideas, and now I'm going to do all the multiplication and division ones. So hopefully this stuff is clear for you. If it's not, you have access to Delta Math. It's free, and you can try them yourself. So I'm going to share my screen. And this is going to be this first piece, and then I'm going to make a quiz when I'm done. I'll probably do videos for each one of these, but we're up to B, which, sorry, we're still on A. So we did knows algorithms and strategies and models and problem situations for adding, subtracting, multiplying, dividing. I did tons of adding and subtracting. Now we're doing multiplying and dividing. If you want access to this free thing, um, feel free to email me if you don't have it. And I'm going to be using Delta Math for this. And here we go. So as soon as it wants to be my friend, right? So here we go. So we're going to do a bunch of problem situations for multiplying and dividing. And hopefully it'll be clear. So this is 1A part 2. And then I'll do all of these. And then I'll make you a quiz to try. And after we do all of these, which will have some for each of them. So here we go, part 2. I have to go to edit. Part 2, and I guess if I click the edit. So try as many of these as you'd like. There's a ton of them. There's tons of ways to multiply and divide. So let's get into it. Let's start with multiplying divisions by 10 whole numbers. So multiplying and dividing. We're going to see tons of ways to see this for us. So we have 96000 divided by 10. You can just cross out 10. I love showing students this way. We can say we break this up into 10 groups. How much will each of them be, or one less? But either way, it's 9,600. There we go. Oh, they're saying just remove the 102. I like it. I like it. So we're on the same page. So that's the first one. Um, let's try one with decimals. Okay, so here we go. Same idea, right? Well, actually, let's go back. Let's do another one of these and see if we have this one. Yeah, so here's another whole number. If it's 33 divided by, oh, this is 33 times 10. If it's 33 times 10, we're adding another 0. So that's 330. If we were dividing by 10, we'd move the decimal one. So that'd be 3.3. So here, this one's 330. Ta-da! Let's do one more. Divided by 10, that's 48. Cool. All right, let's get back into it. So let's do one with decimals. All right, so we have 984 divided, that doesn't look like a 4, divided by 10, we just moved decimal place. That's 98.4. Sweet. Let's do one more. All right, so here's one that might seem a little trickier, but it's not. So 1494.17. If we are dividing by 10, we're making it one decimal place. What? Smaller, not bigger. So boom, this is where the decimal will go. So your answer is 149.417. Magic. So really teaching your students how to move that decimal will be their best friend for these. All right, so here we go. Now we've got a decimal being multiplied by the power of the 10. So 24.33 times 10. We're just moving it one place here. That's 243.3. Ta-da. Let's do a new problem anyway. All right, I knew there's got to be some toughies. So here we go. 63 dot here. I want some space. So if I have 63.44 divided by 1, 1, 2, 4 zeros, right? 1, 2, 3, 4. If I go back 1, 2, 3, 4, that makes it a 1. And I want to make this smaller, right? The whole idea is teaching students to understand we have to make this smaller. So we have to go 1, 2, 3, 4, and there's the decimal. 0.006344. That's how I would show them to do it. Let's see what they say. Nice, I like it. 1, 2 decimal places. Looks just like mine. Beautiful. All right, let's try another one. So multiply by multiples of 10. Ooh, here we go. We got 4,000 times 7,000. What's a good way to think about it? It's 28, and then we have 1, 2, 3, 4, 5, 6 zeros. Let's see if that works. 28, 1, 2, 3, 4, 5, 6. Let's see if that worked. Nice. So what did I do? I multiplied the top two numbers, and then I counted 1, 2, 3, 4, 5, 6. So I went 1, 2, 3, 4, 5, 6. That's what they did too. Ooh. And there's why it works. I just counted the zeros. All right, let's try another one. Oh, okay. So now we have to figure this one out. So we have a 0 already, right? And then we have 1, 2, 3 zeros. So we need something with 2 zeros. So I believe this is going to be times 300. Make it 4 zeros. Nice. Let's do another one. All right, now it's 1, 2, 3, 4. And 5 times 8 is 40. So it's 40. And then it's 1, 2, 3, 4. We got it. All right. So finally, we've got a scale factor. Another way to really think about multiplication. So scale factoring is basically if I have a shape, right? And I know this is 3 and this is 12, and I know this is 4. As long as that they're the same shape, I can think about the scale factors. 3 times 4 is 12. So 4 times 4 would make this missing piece 16. That's how it would work. So fill in the guided sentence below. 24 times 10 relates to 6 times 10. 24 is 4 times 6, right? 24 is 4 times 6. So 24. So 24 times 10. What? This looks crazy. 6 times 10 is 60. Cool. 24 times 10 is 240. Okay. So 24 is 4 times 6, and 24 times 10 is, I believe it's going to be 4 times 6 times 10. Yeah, because 6 times 10 is 40. Wow. They made that so complicated. Oh, what? I got the answer. I put 24 is 4 times 6. So 24 is 4 times 6 times 10. 6 times 10 is 60, and 20. Oh, I put the final answer here. Oh, you gotta be kidding me. All right, let's do another one. I don't want to see the solution. New problem. Okay, so here we go. 30 times 2 relates to 10 times 2. 30 is 3 times 10. Okay. And 30 times 2 is 3 times 10 times 2. 10 times 2 is 20. And 30 times 2 is 60. And what is 20 times 3? 60. That's what they mean by the scale factor. Ta-da! Cool. All right. Fill in the guided sentence below. All right, so this is how I teach how to multiply decimals. We might as well know this. So if I have 0.03 times 9, the first thing I do is pretend this doesn't exist. I just do 3 times 9, which is 27, and then I count. And then I put in the decimals. So all I have to do is count 1, 2 places. So the answer is 0.27. Take away the decimal, count, and then put it in. 0.03 is 1/100th of 3. So 0.03 is 1/100th of 3 times 9. 3 times 9 is 27. So 0.03 is 0.27. Because we're moving to 2 decimal places. That's what this whole thing is. This is 2 places, so we have to have 2 places moved in the answer. Ta-da! Ooh, they got pretty pictures. I like it. All right. Fill in the guide to send us out 0.02 times 7 relates to 2 times 7. All right, well, I might as well just do this one. So I'm going to do 2 times 7 is what? 14. I've got 1, 2, 3, 4 decimal places. So I got to go 1, 2, 3, 4. 0.0014 should be our answer. So this is 1/100th. If the 2 is here, it'd be in the 10th place. 1/100th. 0.07 is 1/100th. This is 1/100th. Oh, wait, sorry. 0.07 is this. So 0.02 and 107 is 1,000th because 1, 2, 3, 4. Oh, wait, 0.02 times 0.07 is 1,000. No, it's 100th. Oh my God. Of this one. Craziness. This is 14. This is 1, 2. So 1, 2. This is 0.14. And this is 0.0014. Woo! Crazy. Making it all crazy hard. I think this way is a little more confusing. I think the easiest thing for you to do if you have this first student 0.02 times 0.07, I would have them visualize it as 2 times 7, which is 14, and then have them count 1, 2, 3, 4 decimals and go 1, 2, 3, 4. And that's how I would show it. I guess the visual is useful too, right? We want to be able to see all the models, right? But I don't know. I think this is just, I get it. So this is the whole piece. This is if it was just 0.02. So that's how you get 0.14 out of it. Then out of this, you do it again. So I get their method. All right. Enter the missing values needed. Okay, so this is another way of showing multiplication, which I've seen a ton, this method. So 6 times 100 is 600. So they do the 6 times the first piece, 6 times the second piece, which is 10, and 6 times the third piece. And 6 times the third piece is 18. And then when you add all three together, you get the answer. I really like this method. I think it's great. So 660, 78. So it's 678. Way easier than just doing 1 times the whole thing. You do the 100th place, the 10th place, the third place, and add them up. I like this a lot. I think this method's really useful for students. All right, let's look at another one. Okay, so here we go. 2 times 12. So we've got tens place and a 2 in the ones place. So 2 times 10 is 20. And 2 times 2 is 4. I like this is a different way of showing it, but I like it. There's 24. Beautiful. All right. So here's another area model. So answer the following to fill in the area model. So which multiple of 10 is closest to 17? I'm going with 20. Cool. Find the area. So it's length times width or base times height. So 2 times 8 is 16. Carry the 0. Nice. Fill in the missing values. So if I wanted to go 20, I went 17, that leaves 3 left over. And what's 8 times 3? That is 24. And then all we have to do is take the whole thing, which is use the total area. Oh, so the green. So it's 160 minus 24. I like this way. This way is different, right? They're all different. They're just showing you other ways to do it. So it's 136 is the answer. I like the area ways. I think they're really nice for students. 136. Ta-da, we got it right. All right. So now we got some two-digit numbers. 60 and 5, 50 and 7. Well, 5 times 6 is 30. Then we've got how many zeros? Well, you should really think about it. I believe it's 3,000, but let's double check it. You know, we could always double check this. This way, 50 times 60. Is it 30,000? It's 3,000. Oh, that's what I got, 3,000. Okay, good. Another way to check it is 60 times 50, 0, 0, 3, 0. Boom. I just multiply the top and end of the zeros. So what's 50 times 5? 250. 5 times 5 is 25, add the 0. 7 times 6 is 42, add the 0. 7 times 5 is 35. We did the chart. All right, according to the model above, and then we got to add them all. So we have 3,000 plus 420 plus 250 plus 35. It's the way they want you to do it. Sorry, I gotta get these down. So we have a 5. We have 8 plus 2, which is 10. Carry the 1. 4, 6, 7. 3,705. That's the way I did it. So obviously we're doing these the same. All right, let's keep it going. All right, so here we go. I'm going to go 23 over here. And then I'll go 59 on the other side. Doesn't matter which way you do it. This top some. Oh, all right, my bad. 23, 50, 9. My bad. So it's 23, 50, and 9. Sorry about that. That's 10 with 2 zeros. This is 15 with 1 0. This is 18 with 1 0. And this is 27. And we could add them up. 1,000 plus 150 plus 180 plus 27, 7. Oh, sorry. 10 plus 5 is 15. Carry the 1. 1357. Ta-da! All right, so now we got some two-digit decimals going on. I'm going to call this 0.20, 0.02, call this 9, call this 0.4. All right, so 9 times 20 is 18, right? Sorry, 9 times 2 is 18. And then I have how many decimals? Well, if I have the 2 there, it's just one decimal, so it's 1.8. That's how I did it. I did 9 times 0.2, 0.2 times 9, which is really 2 times 9, which is 18, one decimal, boom. Same thing here, 0.2 times 0.4. So 2 times 4 is 8. Then I have 1, 2, so 1, 2, so it's 0.08. 9 times 2 is 18. But now I have 1, 2 decimals, so this is 0.18. And a 0.02 times 4 is 8, right? But I have 1, 2, 3. So I have to go 1, 2, 3. So I believe it's 0.0, 1, 2, 3, 1, 2. I need another one. Boom. So there's my chart, right? Now I got to add them all. I'm just going to go to the side. So 1.8 plus 0.18 plus 0.08 plus 0.008. I have 8, I have 16, I have 10. My final answer should be 2.068. Magic. Beautiful. Nicely done. Very well done. All right, so let's do another area model. So we did the area model, then we're going to do algorithms, and we're going to just keep on going. Okay. Click the plus and minus to create fractions. Oh, that's cool. So fraction one, I need 3 parts with 2 parts shaded. Fraction two, I need 5 parts with 3 parts shaded. Okay. Nice. Correct. Now click and drag the second. Oh, fancy. Okay. So basically I cut it and then I put it on the top. So how many rectangles are overlapping? 1, 2, 3, 4, 5, 6. How many rectangles are there altogether? Well, what's 3 times 5 is 15. Oh my God, it is 6. We did it. Might as well do another one because that was cool. All right, we got 1/2, so that's 2 parts. Whoa, 2 parts, 1 part shaded. The next one is going to be 3 parts with 2 parts shaded. All right, then I'm gonna go to the little draggy drag. We've got 2 overlapping, and how many together are 2 times 3, which is 6. So it is, it's 2 6 or 1/3. Should I simplify? See if it works. Let's see. Simplification also works. I love it. Very cool. All right, so we did all of the ones with the area models. So let's do some with the algorithm. 69 times 8. 6 times 9 is 72. So put the 2 here, bar the 7. 8 times 6 is 48. Then you add the 7. 48 plus 7 is 52. What? 48 plus 7 is, I'm a big liar, it's 55. All right. Damn it. All right, let's try another one. 95 times 7. 5 carried the 3. 7 times 9 is 63 plus 3 is 60. Oh, is 66. Nice. Now we got a 2 by 2. That's 10. Carry the 1. 31. Oh, click to cross out the digit you. Oh, so. All right. I wanted to cross this out, but they didn't let me. But now it's 4 times. Well, we have the 0 is the first one because we got to hold the place because it's not 4 times it, it's 40. That's what it means. 4 times 2 is 8. There's nothing left over. And 4 times 6 is 24. And we add them. 0, 0, 9, 0, 7, 0, and 2. I try to click the 2. Yeah, cool. So we carried the 1. There's nothing else we had to carry. You do 5 times this business, then you have to hold the 0. Then you do 4 times the other piece. Oh, that's where they wanted me to do it. Well, okay. I get where they want me to cross out. 5 represents the number 50. So that's why we need the 0 to hold the place. So there we go. 5 times 7 is 35. So here's the 5. There's my 3. 5 times 2 is 10. 10 plus 3 is 13. So there's your final answer down there. That's a 3. That's a 0. It's a 9. It's a 0. That's a 5. That's a 0. We set a 5. And that's a 1. We did it. Nice. So now we're gonna go to 3 by 3, which will be really straightforward for us. 763, 963. So we don't need the 1 anymore. We don't need the 3 anymore. So 6 is really 60, so we need a 0 to represent that on the bottom. And I think I'm gonna pause after this one, and I'll pick it up after wherever we're stopping. So I'm gonna split this into 2 parts. Just getting kind of tired, so I don't think I can really handle doing any more right now. So 0, that's 18. There's your 8. That's your 1. 6 times 6 is 36. Plus 1 is 37. So there's your 7. There's your 3. 6 times 7 is 42. Plus 3 is 45. So there's your 45. We got to cross out the 3, cross out the 1, cross out the 6. We don't need them anymore. Now we're doing 9, which is really 900. So we have to start with not 1, but 2 zeros. 9 times 3 is 27. There's 7. There's our 2. 9 times 6 is 54. 54 plus 2 is 56. There's our 6. There's our 5. 9 times 7 is 63. 63 plus 5 is 68. There's 68. Now we have to add them all. There's 9. No next digit. There's 16, so there's 1 extra digit. There is 14, 16, 17, so here's 17, so there's 1 extra digit. Here is 11, 12, 14, there's 1 extra digit. There is 12 plus 1, which is 13, that's 1 extra digit. And there's your 7, 6 plus 1 is 7. And that should be your final answer. Now, if you ever want to know, there's like a Trachtenberg method to do this really fast in your head. He was sadly a Jewish individual who was in the Holocaust. And if you want to learn how to do these in your head or show them for systems, so basically allow to solve without paper using readily memorized operations. As well, show you what it is. Is there a picture of our good friend Trachtenberg? This is the method he does to do them in his head, but it's what kind of kept him alive during the Holocaust. You got a picture of him? I hate when they don't have pictures of people, right? Isn't that sad? There he is with his cool glasses. So he came up with this system to memorize how to multiply. You can impress people. you want to learn it, it's like people like it because it's like, how do you multiply those fast digits in your head? Well, you can use the trash chamber method and it's right there. So I'm gonna stop this one here. I'll continue it after we've made it up to about half. So we're doing a multiplication algorithm of 3 by 3 with digits. This will be the one we're going to start with when we're moving on. And then I'll finish the division, the multiplying and dividing, because I got the division ones down there. So I hope you enjoy your day and I'll get at it tomorrow. Take care.